Hello everyone, in the previous video I covered solving quadratic equations using middle term breaking, and in this video we'll be covering how to solve quadratics using completing the square method. Now I've covered completing the square method in a previous video of factorization, but just as a brief overview, what it means to complete the squares is going from the general form of a quadratic to this form. When you go from the left hand side to the right hand side, you have completing the squares. So let's do some examples. So the first question I have is x squared plus 2x minus 5. Now the first step to completing the squares equals 0, of course, since we're solving it, is to isolate the x terms in square brackets. So x squared plus 2x minus 5 equals 0. Then what we do is add half of the coefficient of x squared and subtract it as well, since we can't just make additions to our equation. And what I mean by that is the coefficient of the x term is 2 and half of 2 is 1. So we'll add 1 squared and we'll subtract 1 squared to our expression. So what we get is x squared plus 2x plus 1 squared minus 1 squared equals 0. And of course minus 5 as well. Now we can see that this part of our expression is the same as a squared plus 2ab plus b squared, where a equals x and b equals 1. So we can collapse these three terms into a single bracket using our identity, or reverse engineering our identity. So what we're left with inside the square parentheses is x plus 1 whole squared minus 1, because 1 squared is just 1, and the sign didn't flip because what this means is minus 1 whole squared. If the minus was in the bracket as well, the sign would flip, but in this case it's not. Minus 5 equals 0, and if you open the bracket, because we can open the bracket because there's no term over here multiplying, so what we have is x plus 1 whole squared minus 6 equals 0. Now the way to solve equations, of course, is to isolate our x terms. So we can take 6 to this side of the equation and it will become a positive 6. So what we're left with is x plus 1 whole squared equals 6. Now of course we need to somehow get rid of this whole squared, and what we do is we square root both sides. So x plus 1 whole squared square root equals the square root of 6, and the square root and square just cancel out. And why that happens is because when you square root something, it essentially means square rooting something essentially means the power of 1 over 2. So when you square root 4, it means 4 to the power of 1 over 2, and 4 itself is 2 to the power 2. So 2 to the power 2 to the power 1 over 2, this 2 and this 2 gets cancelled out, so you're left with 2. And that's why a whole square and a square root cancel out, because this essentially means x plus 1 whole squared to the power 1 over 2, and the 2 and 2 get cancelled out. So the square root and the whole square get cancelled out, so we're left with x plus 1 equals plus minus under root of 6. Now the plus minus exists because we do not know if the number that was squared to give us 6 was a positive or a negative. What I mean by that is minus 2 whole squared and 2 whole squared will both give me the same answer, 4. So when I'm square rooting 4, I do not know whether to choose 2 or whether to choose minus 2. So we consider both options. So now I have two separate answers in x plus 1 equals under root 6 and x plus 1 equals minus under root 6, and we can plug it into a calculator and that calculator will give us decimal values for this, but let's just leave it in this form only. So our answers are x equals under root 6 minus 1 and x equals minus under root 6 minus 1, and we can leave it like this. Of course, the 1, when I take the 1 to the other side of the equation, it becomes a minus 1. Let's do a few more examples. So x squared minus 12x plus 9 equals 0. Again, we follow the same steps where we isolate the x terms in square brackets. We have the coefficient of x and added squared and subtracted squared as well. So what I mean by that is 12, the half of 12 is 6. So x squared minus 12x will add 6 squared and will also subtract it to nullify the effect, because we can't just make additions to our expressions. The positive 9 of course equals 0. And this part of the equation, a squared minus 2ab plus b squared, where a is x and b is 6, and we can just collapse this into our identity. So what we'll be left with inside the square parentheses is x minus 6 whole squared minus 36, because 6 squared is 36, plus 9 equals 0. So x minus 6 whole squared minus 36 plus 9 equals 0. Minus 36 plus 9 is minus 27. So x minus 6 whole squared minus 27 equals 0, and now to solve this we isolate our x. So how we do that is first take 27 to the other side, so it will become a positive 27. So x minus 6 whole squared equals positive 27, and then we square root both sides, equals the square root of 27. The square root and the whole square get cancelled out, so we're left with x minus 6 equals plus minus under root 27. And then we can form two separate equations where x minus 6 equals 27 and x minus 6 equals negative under root 27, and our answers are x equals under root 27 plus 6 and x equals 6 minus under root 27. The sign of the 6 flips when we take it to the other side of the equation. And now let's just do one final example in a bit more complicated. So let's do 2x squared plus 3x minus 6 equals 0. So of course the first step is to isolate the x terms, right, in square parentheses. So 2x squared plus 3x minus 6 equals 0. Now since 3 has no perfect half, what we'll get is a decimal. So what we need to do is add half of the coefficient of x squared and subtract it squared as well. So the coefficient of x is 3 and half of 3 is 1.5. No, actually what we first need to do is we need to first get rid of the coefficient of x squared, which is a condition to complete the square. The coefficient of x squared must always be 1. So we factor out whichever coefficient x squared has. In this case is 2, so we factor 2 out, and what we're left with inside the bracket is x squared. And when you factor out 2 from 3x, we'll be left with 1.5x minus 6 equals 0. And now we can continue on to completing the square. So now everything is the same. Half of 1.5 is 0.75. So what we need to do is add 0.75 squared and subtract 0.75 squared as well. So 2x squared plus 1.5x plus 0.75 whole squared, just squared, not whole squared, minus 0.75 squared minus 6 equals 0. Now this part, of course, is the same as a squared plus 2ab plus b squared, where a is x and b is 0.75, and we can just collapse it into a plus b whole squared. So what we get is 2 brackets x plus 0.75 whole squared minus 0.75 squared is 0.5625, or in decimals it's, yeah, in decimals it's 0.5625 minus 6 equals 0. Now in this case we can't just simply open the brackets up. What we need to do is multiply these by 2. So we write this as 2 x plus 0.75 whole squared minus 2 times, or actually plus 2 times, minus 0.5625 minus 6 equals 0. 2 x plus 0.75 whole squared. 2 times minus 0.5625 is minus 1.125, and minus 1.25 minus 1.125 minus 6 should just be minus 7.125. Now to solve it, like all others, what we need to do is isolate the x bracket. So first take minus 7.125 to the other side, it becomes a positive 7.125. So 2x plus 0.75 whole squared equals 7.125, and of course we take 2 to the other side, and since it's being multiplied over here, over there it will be a division sign. So x plus 0.75 whole squared equals 7.125 over 2, which is just 3.5625. And then we can just square root both sides, and of course the square root and the whole square cancel out, and what we're left with on the other side is a plus minus under root 3.5625. And now that we have two answers on the right side, we can equate one to the left side to each of these. So x plus 0.75 equals under root 3.5625, the positive one, and x plus 0.75 equals negative 3.5625. And our two answers are x equals under root 3.5625 minus 0.75, and x equals minus under root 3.5625 minus 0.75. Alternatively, you can just use a calculator and it'll give you one decimal answer for both of these.